Hello and welcome. This is the next question. So this is question number 3 for, as I said, the hardest C3 paper. Now, as I said, I've posted the link in the description, but just to reiterate, if you don't want to be bothered clicking on that link and you just, or it doesn't work, then you go to physicsandmaths.com. You go on the maths papers, okay, and you go Edexcel, bronze, silver, gold, and then you go down to gold G4, okay, which is this paper. Now this question is from June 2013, and my personal opinion of this question is not a very good one. Now the first bit that we're going to go through, you might get after a while of looking at the question going, yeah, surely, why didn't I get that before? But then towards the end of that question, to get it in this required form that it wants us to show tan x is equal to a third of tan 40 degrees, okay, so that's in degrees because it's 40, is a little bit weird. Okay, so the first one, as I said, the first part of this question, we're asked to show it is equal to tan x is a third of tan 40. And the first bit, as I said, you might get after a while looking at the question. It is given by the fact that we're x plus 50 and x plus 40, okay? Now, the only things that we've looked at where we're doing a sine of an angle, because x plus 40 represents some kind of angle, remember x is just a number, okay? It's like, say if x was 10, okay, 2 cos 60, but we break that down into x and 50, okay? So basically what we've got here is two angles added together. And the only angles that we look at where we've got the addition rule, the angle addition rule, okay, is the cos angle addition rule, which says the cos of A plus B, okay, is equal to, I'm just doing plus, obviously this works the other way around as well, cos A, cos B, and it's always the opposite of whatever sign is there, okay, because it's positive there, it's added, we take it away, and that's sine A, sine B. So that's why when you get cos A plus A, it's obviously cos squared A plus take sine squared A. But because we've got A and B here, it's cos A, cos B, take sine A, sine B. Okay? Now, the sine of this, okay, so sine A plus B, well, we keep the angle the same, it's sine A, cos B, plus sine B, cos A. Okay, so as you can see, there are two different rules, but as I said, I think they're given in the formula sheet. If not, then it's just something you need to know. But really, as I said, you use them so much for doing past papers, it's something that you should just be able to pick out from, you know, the top drawer of your mind. We're not talking about football for once now, because I'm not wearing a United shirt at the moment for United reasons, because I'm sure they've just lost a game at some point. Okay, so what we do here is, well, we correspond the A and B with the values we're given, okay? So the first thing that we need to do, well, we're told this is a situation, 2 cos x plus 50 is equal to sine x plus 40. Now, we're not asked to prove that 2 cos x plus 50 is equal to sine x plus 40. We're asked to prove that the combination of them two is the same as saying tan x is equal to a third of tan 40. So what we need to do, and the only thing we can do, well, obviously, what you might want to do is divide both sides by cos, but because they're different angles, we can't do that to get tan x, okay? Purely because, well, these are x and 40, they're not the same angle. So what we need to do is split this up, as I've proved here, into the addition formula. Okay, so it's 2 cos, because this is 2 cos x plus 50, not just cos x plus 50, we need to do 2 times what cos x plus 50. So if we assume A to be x in this situation and B to be 50, then you just sub A here, so A says x, B is 50, okay? And you write the equation out, okay? So it's cos x times cos 50, take sine x, sine 50. Okay? And we're told that it's equal to sine x plus 40. Okay, so you do that equal to sine x plus 40. Sub in a to be x, b to be 40. Okay, so it's sine a, which we said was x, times cos b, which is 50. Okay, so it's times cos 50. And then we add sine b, b being 50, so it's sine 50 cos x. Now we simplify it and see where we can go from this. There's no point trying to rearrange this just yet because, well, I'll explain why in a minute. Okay, so it's 2 cos x cos 50. Take 2 sine x sine 50. We're told that is equal, nothing changed on the right hand side, sine x cos 50 plus sine 50 cos x. Okay, so I do apologise, I'm not the quickest at writing. Okay, so where do we go from here? Well, what we need to do, really, obviously we need to have it in terms of tan. Okay, so as I said, it doesn't really matter. I don't think if you necessarily do this, but what I did is, okay, I've got all the cos x's onto one side and all the sine x's onto one side. Now you quite clearly can't just get all the sines on this side and all the cos's on this side, because what we've got here is we've got cos x and cos, a sine and a sine and a cos and a sine and a cos, and it's going to be quite hard to split them two up. Sure, you could do it. You could probably do it through, standard dividing both sides by cos 50 and then sine 40 or whatever you'd have to do. But in essence, you'd get very mixed up. So what I would do is rearrange it. Okay, so you get all the cos x's on one side and all the sine x's on the other side. Okay, so essentially what we're going to do is move this 2 sine x sine 50 over to the right hand side and move this cos x sine 50 to the left hand side. Okay, so in other words, we're adding 2 sine x sine 50 and taking away cos x sine 50 or sine 50 cos x. Okay, so on the left hand side we've got 2 cos x cos 50. And remember, we're taking away sine 50 cos x on both sides, so it's take away sine 50 cos x or cos x sine 50. It means the same thing. And that's equal to sine x cos 50. Okay, and as I said, we're adding 2 sine x sine 50 to both sides. So we add 2 sine x sine 50. Okay, so what we want here is sine over cos. Right, we've quite clearly got sine x's in these two. These two both have a sine x in there, and these two both have a cos x in there. And what we want is tan x equals something, and we can't do cos x cos 50 over tan x. That would be stupendously weird to try and figure that out. And unless 50 was x, which it isn't, then we wouldn't be able to work that out. Okay, so what we need to do is take out the cos x and the sine x as a common factor on whichever side has it as a common factor. Now, as I said, on the left side, we're going to take cos x as a common factor. Now, I'm not going to take 2 cos x out of this first bit because, well, there's not a 2 cos x on this side. So we're just going to take cos x out of the left-hand side as a common factor. So cos x, and then we work our way down. Okay, so it's cos x brackets 2 cos 50. Okay, take sine 50. And you close brackets. I'm going to do the same on this side, but obviously we're going to take out sine x as a common factor. I do apologise. So it's therefore sine x brackets cos 50 plus sine 50. Now, what we want, as I said, is tan x to be on one side, okay? So what we're going to do, obviously, because as I said, you can do this in a number of ways, but I'm going to try and do it in the most obvious way. We know sine x over cos x is tan x, so we want to divide both sides by cos x. And if we do that, quite clearly what happens is if we do cos x over cos x, well, that just kind of cancels it out, so we can get rid of that, but you have to remember it was there at that stage. And sine x over cos x is tan x. So that's all we can do so far. But we want tan x to be equal to a third of tan 40. Now, just bear in mind we want tan x as a subject. It quite clearly isn't the subject on the equation we've got so far. So let's make it the subject. I don't think I've ever done this right. I was lost cos 40. Great. Sorry, I do apologise. I've made a little bit of a mistake here. But hopefully it's not too bad. The math isn't right. I've just put cos 50 instead of cos 40 in sin. Sorry, I put sin 50 instead of... look, let's just work out where I've gone wrong here. So I do apologise, but I can't bother redoing this video again. Well, I haven't redone it before, obviously. Okay, so what I'm going to do is actually I'm just going to pause the video and then sort this mess out. As I said, the maths isn't wrong. It's just I've wrote, sorry, the correct way of saying it, 40 where there should be 50. But as I said, I'll just pause the video and rectify it, and then I'll just explain where you should write your 40s. Right, so hello and welcome back. I'm sorry it's a little bit zoomed in, but as I said, I'm just going to point out where I'm wrong. I kind of want to zoom in rather than faff around pointing. Okay, so as I said, what I didn't assume here is in the sine equation, it's obviously x plus 40, and I assumed it was x plus 50. Well, I didn't. I knew that, I just couldn't be bothered putting in 40, because, you know, I'd be a rebellious kid. So because this sine equation there, that you can see on the board, the b should have been 50. So if we relate that to the equation over here, actually I've not even corrected that. So that cos there should read sine x cos 40 plus sine 40 cos x, okay, as it says in the second line. I do apologise. Okay, so that is the second line, alright? So that's what the second line should read. The rest of it is exactly the same as 8. So 2 cos x cos 50, take 2 sine x sine 50 equals sine x cos 40 plus sine 40 cos x. Okay, and now so we take this over to the next line, sorry, and we simplify as we did before. So the maths wasn't wrong. So obviously you follow the arrows, just switch them round as you did before. So that leaves 2 cos x cos 50, take sine 40 cos x equals sine x cos 40 plus 2 sine x sine 50. Okay, because remember we've moved that there over to the right hand side, which gives us plus 2 sine x 50, sine 50. One more actually mistake as well. Obviously, it's just a case now of using that bit of information and simplifying it down. But over there, so on the bottom right of the screen there, just kind of zoom in a little bit. So that plus 2 sine 50, I had that as just sine 50, so you may want to change that because I think I made a little bit of a mistake there. But apart from that, it is all correct. So what we're going to do now is continue with this question. So I do apologise about that little mistake there, but hopefully it wasn't too bad. As I said, the math wasn't right. It was right. My English clearly isn't. So there's no need to, you know, get all worried about me getting the answer wrong. Okay. So as I said, we're not even finished yet. So what we need to do is just get this in terms of tan x. So what we do is divide both sides by cos 40 plus 2 sine 50. Okay, so that leaves us tan x as a subject. Okay, so tan x is equal to 2 cos 50 take sine 40. And that is all over cos 40 plus 2 sine 50. Okay, so that's as far as theoretically you could get. However, this is where the tricky part comes in. Now, I'm assuming, apart from my rather crude attempt at copying down and using a formula, that it should have been fairly straightforward. This is actually the harder bit. Now, I'll try and explain it through the way that my thought process took me, even though for some people it probably makes it more confusing. So what we need, remember you've got to bear in mind what form it wants in. It wants it in tan x equals a third of tan 40. Now quite clearly, we need this in terms of tan. More importantly, we all need it to the angle of 40 degrees. But we can't just change 2 cos 50 to 2 cos 40. Well, quite clearly it gives a different answer. So, as I said, what we need is the top in terms of theory of sine and the bottom in terms of cos. But we need the angle to be all 40, okay? And that is because what we need is the bottom to be 3 cos 40 and the top to be 1 sine 40, okay, or sine 40, to enable us to get a third of tan 40, okay? But to do that, we're going to need to convert cos 50 to sine. And as I said, we need it all in terms of the angle of 40 degrees, because that's the angle that's given in the question. Now, the harder bit of this is realising that cos 50 is the same as sine 40, and sine 50 is the same as cos 40. So what we do is, as I said, I tried to explain the way you would think about it. So tan x is equal to 2 cos 50, well, I'm sorry, cos 50 is the same as sine 40. So 2 times sine 40, which is the same as 2 times cos 50, takes sine 40. And that's over, well, we want cos on the bottom, so we're going to leave cos 40, we're not going to change that, plus 2 cos 40, instead of 2 sine 50. Okay, so that leaves us tan x is equal to sine 40 on the top, when we cancel them two down, over 3 cos 40. Okay, but that isn't the answer. We want it in tan x equals a third of tan 40. So what we do now, sine over cos, tan, the angles are the same, and it's just tan x equals a third of tan 40. Okay, so that is your official answer. Now, as I said, that was an extremely difficult question. Probably one of the, if not hardest on this question. You can quite easily see why this is a mix of the hardest questions. Remember, this is only C3. We're not even into C4 territory yet. But as I said, some people C3 is harder than C4. Okay, so that is very, very difficult. But not out of the woods yet. We've still got another part of question 3 to go. Now, unfortunately, what I'm going to have to do is rub some of that off. More importantly, what I'm going to do is rub this bit off, because I think this is more the crux of the question. This is just a case of applying the formula to the answer. Okay, really, I could even rub that off, because said we're not going to be using that. But just for the benefit of those who haven't been bothered writing it down, I'm going to keep the right hand side, but I'm just going to rub off the middle towards the bottom kind of thing. Okay, and that's only to give me a bit more room. Okay, because obviously we've got to move on to part B. And the most important thing about part B is that it is very similar. Well, it's not very similar. We use our knowledge, as we generally do in these things, from part B, from part A even. So part B, the question says, hence solving between for theta between 0 and 360, 2 cos of 2 theta plus 50 degrees is equal to sine 2 theta plus 40 degrees. Now, something should jump at you straight away. First of all, they wouldn't give you something that random just out of the blue. So it's got to be related to something we've just done. And quite clearly, this is very, very similar to 2 cos x plus 50 is equal to sine x plus 40. Now, the only difference between them two is they've replaced x with 2 theta. So you might want to write a little note somewhere. As I said, it's not for, it didn't give you any additional marks, but it's nice to think of it. X is equal to 2 theta. Obviously, you might not want to do this by the examiner, but we'll see. But it's nice to relate that, because if you wrote x to be 2 theta and put x in there as 2 theta, you would end up with that equation, which you just worked out how to rearrange it, which is obviously going to be of some value to this question. Now, it wants it to one decimal. We want to figure out what theta is. Now, well, we've got this answer, and what we essentially would do, if we put x to be 2 theta, we'd work out what this is and simplify it as we did in the end part of the last question. And we would get tan x to be a third of tan 40. Or 3 tan x equals tan 40, whichever way around you want to think of it. So, well, we've got x here, but we've said x is equal to 2 theta. So, we're going to get this equation. So, you might want to write it out again. So, tan x is equal to a third of tan 40. Okay, and we said x is 2 theta, so you just replace x with 2 theta. So tan of 2 theta is equal to a third of tan 40. and quite clearly a third of tan 40 is workoutable. You will get an answer for that, okay? And if you were to work that out, and you can shove that in your calculator, let me see what you should get. You should get 0.2796, etc. Okay, so tan of 2 theta is equal to 0.2796, okay? So what we want is theta on its own. But whenever we get an angle which is not directly theta, we work out what that is, okay? So we tan inverse both sides to get what 2 theta is, okay? So 2 theta is equal to the tan inverse of this 0.2796 malarkey. Okay, so you get what 2 theta is. So if you were to work that out, you would get 2 theta is 15.7. Sorry, 15.626. Etc. degrees. Okay, so that'd be 2 theta. Now, as I said, the way you would go from here, well, our range initially, just for theta, was between 0 and 360. But because we're looking at 2 theta, the range of 2 theta, we double the range, because we're going to halve the answers again, okay, to get us to work out theta. Now, you wouldn't just halve that to get theta, because you would be missing out a few answers. It's like if you've got x squared equals x, you wouldn't divide both sides by x, because you'd be losing a result. A similar kind of thing to this. Okay, so what we do is, initially in our heads, double the range. So therefore we get 2 theta to be between 0 and 720. In other words, 2 turns. And I say 2 turns because the way I work these kind of things out is through the cast diagram. As I said, there's a playlist video on that, so please check that out if you're not 100% on the cast diagram. But I'm going to go through it anyway. Okay, so the cast diagram says cosine all sine and tan. And that goes bottom right is where cosine is positive. Bottom right is where cosine is positive, top right is where all of them are positive, top left is where sine is positive, and bottom left is where tan is positive. But we're looking at tan here, and obviously all of them as well, because where tan is positive, they are all positive, includes tan being positive. Okay, because the reason it's positive is because the tan of the answer is positive, and that's what we mean by, well, it's tan positive, is the answer positive, not necessarily the angle that's being tanned. Okay, so what we do is we worked out what 2 theta was, which is 15.626, and we look where tan and all of them are positive, okay, and that gives us our diagonal line, and we get 15.626 degrees here and 15.626 degrees here. Okay, and what we do then is we just simply work out, because this is 0 and 360, okay, so we'd hit the first one, 15.26, go again, work out what the next hit was, and then go again and again. So ideally we should get 4 results. Well, when I say 4, that's you keep going and keep going until you think you've got enough, and you keep going and keep going until you can't get any more. Well, obviously you can keep going forever, but ideally, 2 full turns is 720 degrees, which is obviously double 360, so you wouldn't want to do any more than 2 turns, because when you half it, then it will be over 360. Okay, so basically, I'll just, I'm going to try and draw lines on there, but you should get 2 theta to be, sorry, I have the answers out, that's why I was looking over there. 2 theta is 15.626, obviously that'd be your first hit, and then you do that again, so you do 180 plus 15.626, which would be 159.626, right? And then you do 15.626 plus 360, which would get you 375.626, okay? And then you'd be 360 plus 195.626. Which would get you 555.626. Now you couldn't do any more than that, because if you did, the next answer you'd get is quite clearly over 720. Okay, if you were to work it out, what you'd do is add 360 to 375, which is clearly more than double 360. okay? But you could do that and end up crossing it out, showing you had considered that, but you wouldn't get any more marks for it. So what we need to do now is half all of these answers to get our end answer. So it's theta is equal to 7.813, 97.813, 187.813, and finally 277.813. And remember, they are all in degrees, so you need to attach the degree sign to them. But that is your end answer. Okay? So, quite a difficult question, I think you'll agree. But hopefully I've tried to talk you through it a little bit. I'm sorry for keep referring to my answers, but you know, as I proved earlier in this question, I did make a little bit of an error. So, try not to do that again. Anyway, thanks for watching. That was June 2013. I think it was question 3 on that as well. But there's no harm doing the video again. But when I do get around to putting June 2013 up, or I might just copy it in. This might be, I don't know, whatever the hell I'll do. Probably save time and not do the video here. But anyway, thanks for watching. Hopefully it's been of some help to you, and we'll see you in the next video. Hopefully question 4.